Hello everyone, I'd like to introduce my Bachelor Thesis, which is focused on a spatio-temporal reconstruction of the landslide area Soláň activity. For purposes of my research, the main goal was to detect landslide movements for the entire landslide body and even for each landslide part with similar morphology. The next goal was aim at defining possible landslide triggers. And the last aim was to find out the pros and cons of this methodology. First of all, before I start to talk about the approaches I use, I'd like to give you a closer look at the location and characteristic of the study site. I studied a complex landslide in the Vsetínské vrchy mountains. In the picture on the left, the precise position of the study area is defined by the red dot. It's near the Velké Karlovice town in the Raďkov Valley near the Soláň recreational area. To see the morphology of the study site, on the right there is a zoomed landslide I studied. You can see the cursor, I'm just showing the studied landslide. There is a distinct headscarp, two blocks, and accumulations. There are not only landslides in the area. Here is the debris flow path and earth flows. As I mentioned, studied landslide may be classified as a complex slope deformation. It's bedded into fresh bedrock. I did a simplified geomorphologic map, as you can see here on the right. Landslide has a distinct several meter high headscarp, and it's made of blocks and landslide accumulations. It's evident that landslide is active because there are many trees that are tilted and have stretched roots, especially on the headscarp and on the smaller blocks above the earth flows. Here are the blocks. There is the earth flow paths, and there are the earth flow paths, and here is the path of the debris flow. Apart from trees and other mass movements like debris flows and earth flows, there are three tension cracks that are clearly visible in the terrain. The longest one is here, and two not so long are here in the accumulation part. I divided or defined 5 landslide zones according to the similarities in morphology. So in the map, each zone has different color. Finally, I'll tell you something about the methods I use. I use mainly dendrogeomorphologic methods to obtain dendrogeomorphologic data. 255 Norway spruces were sampled. I used increment borer, so I got cores with diameter of 0.5 centimeters. Then in laboratory, cores were stabilized by wooden supports and sanded to make tree rings more visible. Then width of each tree ring was measured with a use of stereoscopic microscope and measuring device timetable. After that, I processed measured data in past4 software, so each tree ring got its precise year. For the main determination of possible landslide years, I use growth disturbances. I work with compression wood, which is that brownish wood you can see on the right. It's strong version, it's mild, weaker version, and always the first year was assigned as a possible landslide year. Then I used abrupt growth suppression. Again, you can see the suppression here, and this is the first year of the suppression, so it is supposed to be the landslide year. And the dream chronology starts from the 1960s. because those trees weren't too old. As a first step, I compared during chronology by summarizing all recorded disturbances. You can see some of the chronology on the right. So then I was able to tell which year is probably the landslide one, according to the number of disturbances by particular years. Because landslide movements often influence trees in logical patterns. For example, they create clusters or occur at specific parts of the landslide. That's why I added position of the disturbed trees into the map to see its spatio-temporal pattern. Certain landslide years are just those years when disturbed trees have this logical pattern, like in the picture on the right, where you can see those trees are clustering after the event in 1997. Now, when landslide years are defined, I try to link the relationship between landslide movements and precipitation. I got meteorological data from Velké Karlovice and from archives. Main aim was to find out the possible landslide triggers. Finally, I focus on the characteristic of growth disturbances in the samples. For example, how long compression would persist in the tree rings, how strong the compression wood was, and whether abrupt growth suppression in the trees or around the study site is if it is clustered or if it is like dispersed. Now the results. Studied landslide is active nowadays. Landslide blocks move in years 1981, 1982, and 1983 in a row, and 2000. Shallow landsliding of landslide accumulations occurred in 1997 and 2002. I found out that landslide movements were triggered by above average annual precipitation in case of landslide blocks, whereas extreme daily precipitation triggered landsliding in the shallow landslide accumulations. In terms of dendrogeomorphologic methodology, reaction would seem to be helpful in detection of landslide movements, but a lot of limitation occurred, and unfortunately results from abrupt growth suppression analysis were not reliable. If you are interested in my topic, data from my work were used in a publication. Link is below. And I hope you like my presentation and thank you for your attention.